Welcome back guys, hope you all are doing well, and today we are going to solve lab number 1 from server-side request forgery module, and this is again the server-side vulnerability. If you did not watch the previous video where I brief about this vulnerability, how it could be found and how it could be exploited and what are the damage it could cause, so you can watch that. And if you did not subscribe the channel, please subscribe and hit the bell icon so that you get the notification on time. That's been said, a little disclaimer as always for you: this video and its contents are only for educational and awareness purpose, and I do not support any unethical or illegal act. That's been said, let's see what the lab is all about. So basic SSRF against local server. So there are two kind of SSRF vulnerabilities. One is regular or classic SSRF, and another one is blind SSRF or out of band SSRF vulnerability. So this lab is all about basic SSRF. So this lab has a stock check feature which fetches data from an internal server. To solve the lab, change the stock check URL to access the admin interface at this, and then delete the Carlos account. Fine. What we are going to do actually in this lab is, suppose this is your front-end application with which you are going to interact. So this application is published over internet, and any user come to this online shopping application, it is going to directly interact with this application, right? So this application has a lot of products, and if you want to purchase a product, you go to the details of that product, and then you first of all check whether the product is available or not. So the instant when you check the product whether it's in stock or not, so that request goes to an internal API server, and that API server checks whether this product what you are asking for is in the stock or not. If it is in the stock, how many units are there of that product, and it is going to reply back to this front-end application, and then this application is going to respond you, and that response will be rendered on your page on your web browser, right? So once you see okay, the product is there, then you go further and you proceed to purchase the product. Now there is a business logic which you need to understand first, that how the application is behaving to perform a particular task, right? So okay, as a user you do not know what this application is actually doing, how a transaction is going to happen. But if you are a hacker or a penetration tester, you have the techniques, you have the tools, and you have the concepts in your hand. So that knowledge you can use to even go deeper to see the flow of the application to perform a particular task. So here, that's been said, let's jump to the lab. One more thing I want to mention, that if you see this closely, you can see to solve the lab, change the stock check URL to access the admin interface, right? So we need to access somehow this admin interface, and from there we need to delete this Carlos account. Okay, so now back to the application. This is our application. I already start the burp proxy here, so I'm gonna off the intercept and then just manage a bit so that we can see both of the windows simultaneously. Now I'm going to choose a product, let's see this one, and I'm going to actually go back, start the burp proxy on your browser, and then choose a product. So once I choose this product, okay, I'm going to first see how many products are available in the stock. So as you can see, once we choose the product, we get here a request, get request, and the product we choose has a product ID equal to 1. Fine. Now if we see this request closely, there is nothing interesting which convince you that this application has SSRF vulnerability, or you can try the SSRF vulnerability test. So but once we go to the check stock, we got one more request here, and that request is a post request. And if we see this request closely, we can see in the end of this request there is a stock API parameter which has a URL value, and that URL value take us somewhere else. So once I right click and just copy this value, go to the decoder and paste that and just click the smart decode. So these all the URL encoded special characters can be decoded, and you can clearly see the URL to which this application is sending the request to check how many products are there. So it's saying okay, in the store ID 1 means there is 3 stores, London, Paris and Milan. So London has store ID 1, Paris has a store ID 2 and Milan has store ID 3. Because we checked the stock in the London stock, so it's saying okay, in the product in the store ID 1, how many products that have the product ID 1. So there are 493 units. Fine. That means this request is actually sending another request to somewhere else. It could be inside your network, or it could be outside of your network, or it could be an external server. Fine. So now we know that there could be SSRF, and we can test SSRF in this condition where the front end server is sending some request to check the stock to somewhere else. Now how we will check it? We can check it by sending this request first to the repeater. Go to the repeater and just send this request, so we can check whether the request is responding well or not. So as you can see, we have 859 products, although if you check here, before there are 493 units, now it's different, but we are getting the number of products. Fine. Now we can test it like, let's say https:// let's say google.com, and just send this request. So maybe this request is blocked from the server because the Portswigger or web application security, because this is a lab, so they put some kind of filter with which they can identify that the request you are not going to send to any external domain. So as you can see here, our request is blocked, could not connect to external stock check service. So this is a good security, that if your server is inside your network, then you cannot send, or application will not send anything outside of that domain. But the thing is, we know that okay, there could be something else interesting. We cannot send the request to any external domain, but maybe we can send the request to internal domain. As a tester, what I will do now, I will go for the directory enumeration or directory busting, and I am going to perform it with GoBuster. So let's say GoBuster directory enumeration space -w for the word list, and I'm going to use user share word list, seclist discovery web contents, and inside it there is a file raft small. I'm not going to use big one. Directory, and let's say lowercase. Now I will specify space -u, which is for the URL, and the URL we have here is this. So copy that, come back here and just Ctrl+Shift+V to paste it. And I don't want this, right? And now I'm going to choose number of threads. So let's say 20, and space -k to avoid or ignore the SSL warnings, and just hit enter. So this will actually check all possible directories could be there from the word list, and whatever directory is there, and the application give us some status code. So we will know that okay, as you can see here, we got one directory which is /admin, but the status code is 401. So that means we cannot access this this particular directory on the application server, but this directory exists on the server, right? So I'm going to Ctrl+C to hunt this /admin. So let's see, we are going to try whether we can access this /admin or not. So delete this and just put, let's say, admin, and just hit enter. So once we hit enter, you can see we got some message, and the message is admin interface only available if logged in user is administrator, or if you log in as administrator only, then you can access the admin panel or this endpoint. And there is one more, or if you requested from loopback. So even this message for me as a tester is information disclosure. Why? This message up to here is okay, that if someone try to access this /admin, so there could be a message that okay, only administrator is authorized to access this resource. But this part is information disclosure, because here it's going to mention that you can access this /admin if you request from the loopback address, that means from the local host. So loopback IP is going to be 127.0.0.1, and you can also by name you can also access as localhost. So that means we can access this /admin directory if we request from the loopback or from the localhost or from this IP. But the thing is, if we come here and if we see the diagram here, so if you send this request to this web application, then web application is going to see you or see your IP as IP from the internet. But because you have the SSRF vulnerability, and you can tell this application to go where, whatever you want to mention. So we can try it, like instead of going to external domain, we can say okay, to check the stock, go where, go to localhost, fine, and go to /admin, fine, and just send this request. So once we send this request, you can see 200 okay, and the response is something else, because if you go to check the stock like this, so the response is 200 okay, but the response has only the unit number of the product available in the particular stock. But if you send this request as loopback /admin, you can see you get the page source of admin page, fine, and if you go down, you can see there is a link to delete the Carlos account, there is a link to delete Wiener account, and in the panel you have option like admin panel. Now if you want to confirm it, just right click, show response in the browser, copy that, make sure to enable the burp proxy on the browser, click on new tab and just paste that URL and hit enter. So now you can see that right now we are accessing admin panel and we can delete these users. But if you delete the user from this web browser, then it will not work. Why? Because once you give the instruction to delete this Carlos account, again the request is automatically generated, and the application will see this request coming from internet IP, not from localhost, and it will deny the request or drop the request before performing the particular task. Fine. So to delete the Carlos account, again what you need to do here, because you know that from the page source, you know there is a endpoint to delete a particular user. So I'm going to copy this endpoint, and here I'm going to put it like this and just send this request, and this will delete the Carlos account. And as you can see, 302 found, and it is going to redirect us to somewhere. So here you can also see, congratulations, you solved the lab. But now if you want to again see, if we actually follow the redirection, then it is going to give us a error like 401 unauthorized, because once we follow the redirection, my browser or this burp suite is going to send a request, but the request will go to the application from my IP, not from the local host, and that's why it's saying unauthorized. But if you want to confirm whether this user is deleted or not, you can again go back to the same API request, and here just click on and just mention localhost/admin page, send the request again, and copy this. You can right click and choose show response in browser, copy this URL, and just paste the URL here, hit enter, and this time you will see Carlos account is not here. That means Carlos account is deleted successfully. So you can see how much damage a threat actor can cause if he successfully exploited the SSRF vulnerability. So that's it for this video. Hope you understand it. If you like the content, please like, subscribe and share. See you in the next video. Bye.